may be complex. So for now, we are starting with the simpler ones, and as we proceed further, we'll be going into more complex block diagrams, how to resolve more complex blocks in a system. So we need to reduce this block diagram and also find the transfer function. If you want to find the transfer function, how can we do it? Now we don't know the value of a row of x, and we don't know the value of c of x. So it's a problem. So in order to, we were having, it's only if we are having a single block in between a row of x and c of x, that is when we can consider that as a transfer function of a system. But when you are having a multiple blocks, you cannot consider that as a transfer function. So our aim is to reduce these multiple blocks to become a single block using the block diagram reduction rule. So first of all, they say find the transfer function of the system below. So looking at this system now, how can we start? Because the starting is always whenever you have gotten the solution, the first step, if you have gotten the first step, you have no challenge any longer. You can be able to resolve all the multiple blocks into a single block. So our first step is very, very important. But looking at this block now, you can see we have G1 and G2. They are on the same lane. You cannot say let's combine these two blocks in series. You can't do that. The reason is because there is a disturbance over here that is hindering this G1 and G2 to come together. So it can be possible. So what we are going to do is we are going to move these branch points in order to make our work easier. We are going to move this branch point. We are going to push it over to this place. So you can remember in the rule, they said whenever you move a branch point ahead of the block, whenever you move a branch point ahead of the block, there is an effect that you are going to add the inverse of the actual gain. So this is the actual gain, G1 now. G1 is the actual gain. So we are going to add the inverse of the actual gain on the top of that branch point you are moving. So now see what we are going to do now. Let me put it over here so that we can see it. So first of all, we say moving the branch point ahead of the block. Ahead of the block. So we say a row of x as the input, we have plus, minus. So now we want to push this point now over to this place. So we have G1, and this is the point. So what we are going to have here now is G3 all over G1. So we have added the actual gain in the system. So we bring it over to this place. Say plus this C of x. So drawing it now, we have this is our H, and this is our G2 connected here. So as you can see now, this block now can be easily modified. We can easily modify this block. So we want to, first of all, we want to take this part. Let's take this part. And remember that the formula for a negative feedback is G all over 1 plus GH. That's the formula for a negative feedback. So now what we want to do is to resolve this part. We want to resolve this part now. So we will be having a row of x. We have resolved here now to become a single block. So we'll have, what we will have is we'll have g1 all over 1 plus g1h. So the next one we have to do is to resolve this. We have to resolve this now. As you can see, these two blocks are in parallel. These two blocks are in parallel, and it has no feedback, unlike this. So whenever you are resolving, whenever you are combining blocks in parallel, you are going to add those blocks. So what we have here is g3 all over g1 plus g2. So here we have c of x. So the next we are going to do is the two blocks, we are going to combine them in series. So we are going to combine these two blocks in series. We'll be having a row of x, we'll be having g1 all over 1 plus g1h times g3 all over g1 plus g2. So as you can see now, we have one block in between a row of x. So this now can be seen, or you can now call this the transfer function of a system. So to resolve it, we are going to now do, what we now have to do is c of x all over a row of x will now be what? 1 plus g1 times g1 g3 plus g2 all over what? G1. So this one will cancel this. So this one will cancel this. So we are left with what? C of x all over a row of x is equals to g1 g3 plus g2 all over 1 plus g1h. So this is the answer.